So, good morning, everyone. Today's session is basically we want to give some introduction about virtual machines, what is the purpose of virtual machines, and in what ways it will help you. Additionally, along with that, we are going to do some Linux basics as well. Okay. I'm not sure to what extent everyone in this class know about the virtual machines, but I would be doing from ground level as how this evolved and what is the purpose, how we are going to create them, and how we are going to manage them within your systems so that it becomes easy for you to have multiple operating systems that can be run, executed, and you can perform whatever activities that you are planning to do, like prototypes or POCs or whatever it is. I mean, the evolution of virtual machine initially started by IBM when they had mainframes where it was so costly hardware. In order to set up a new environment, in order to give a dedicated environment to a user, to a group, or to a team, it's too clumsy and too costly affair. Then at that point, there were some engineers, maybe in 1960s, I don't know, whatever that year is, they came up with the logic of virtual machines so they can virtualize as if you feel it's a machine for you, but it is a software kind of a piece. Everything is based out of software, which represent or present you a layer which feel as if you feel it's like a physical machine for you. Now, in order to create a machine or in order to create an server, what are the main things that we need to build? It could be a desktop, it could be a laptop, it could be a server, it could be anything. And in order to build a computer, let's say, maybe I should not say server. To build a computer, the main core things that you need is CPU, hard disk, memory. These are the main three things which require in order to install, configure, or run, or do any programming or play with systems so that you can write some programs, you can do some activities, you can install and all those things. So how in the virtual world, then how do you get those three components is the key. So what it does is it do share some of your physical hardware on which you are creating this virtual environment. Now, how do we create this virtual environment? Okay, good. I know I have like 2-core CPU, 8-core CPU, 16-core CPUs. Nowadays, hardware is so pretty cheap, and you have 16 GB RAM, 32 GB RAM, you have 1 terabyte disk space on which, let's say, you are running your Windows operating system. Now, if I want to create my own virtual environment, isolated virtual environment to pretend as if it's like a new machine, so I can install whatever software I need, how you can build that. So you need to do that. In order to do that, you need some softwares, which are called virtualization softwares. There are a lot of virtualization softwares available in the market, of which the predominant and more popular are VMware, which is commercial product. They do not provide any free software. And along with that, there is an open source piece called Oracle VirtualBox. Initially, VirtualBox is not from Oracle, but they bought VirtualBox. Now, what does this VirtualBox do, or what does this VMware does? These softwares, basically, they allocate some of the hardware power that you have on the machine that you're trying to install and present them in the form of raw format so that you can install, configure, tune, and do whatever you need to with those hardware components. But how you are going to do is basically you need to download the softwares, install, configure, and start doing your stuff. Now, how do we get this software? So as I said, VMware is itself a company. They have a lot of projects like products like virtual machine, then ESX server, and other products. I am not much familiar with VMware products though, but along with that, as I said, there is another product called VirtualBox, which is free, open source, and hence most of the community uses VirtualBox in order to build those virtual machines. Now, if the things that you need before you even start installing this product is you need to understand how much resource or how much power or how much capacity does your system has, and how much you can allocate in order to create those virtual machines. So let's say you have an 4-core, 16 GB RAM, 1 terabyte disk space. Now, how do you know how much is free, how much is not free? I mean, as a user, let's consider our laptop or a desktop. In that scenario, as a day-to-day user, you will know to what capacity you are going to use them. What is the purpose of the machine that you're trying to use? Then based on that, you need to do some mathematical analysis and say, okay, I know that out of my 4 cores, at the most, I'm using 2 cores, and I am using only 4 GB of RAM, of which operating system and some of the tools that you're going to run them. And at the same time, disk space is very easy to identify. You can see my computer properties and say, okay, how much is being used and how much is free. Now, once you have some idea about how much resource you can allocate, then you can start thinking about creating the virtual machines after installing the software. What I did though is I basically pre-downloaded the software, but as a test, what I could do is I can go to this is where you can download the software from. I mean, every day, a lot of releases will be done. I think they have like monthly one release, but usually I prefer to take one release candidate than the latest one. The reason being, sometimes you might see some issues where you don't want to have those errors on your screen. So let's say this is your laptop. On this, you are going to install the software called VirtualBox. Now, this VirtualBox, as I said, we need CPU. Then along with the CPU, we need RAM and we need hard disk space. But those are not, technically speaking, yes, they make the core components, then RAM. But along with that, you need a means to communicate these virtual machines. How can you communicate to these virtual machines? For instance, within our laptop, there is some additional component called network adapter, right? What does it do? The purpose of this adapter is to connect to machines. It could be machine, it could be internet, it could be LAN, it could be WAN, whatever it is. If you want to access this machine, or if you want to access any of the other machines, other data available in different location, different source, then you need something called networking. So along with the CPU, hard disk, and RAM, you need something called adapters, called network adapters. But the problem is, on your machine, you have only one adapter on your laptop. Then how you're going to build virtual adapters on top of it? So these are all software based. So you can have, when you install this virtual machine, then you can have up to 4 network adapters. Now, why we need 4, why it's only 4, we'll see that later. But technically, using command line, you can go to maximum of 8, I think, if I'm not wrong. Like for each, you can have a backup. So that's why they say virtually you will see once you install the software as 4, but behind the scenes, you can make this as 8. One is like failover, or you can make them as all individual. So along with network adapter, what else we think we need? You need graphical user interface, right? And I don't know how many people have built your desktops from scratch. Technically speaking, when you install some software, you need something called drivers. Drivers are nothing but interfaces in order to communicate with the hardware devices. They can understand what language it can communicate so that it gives you the specific output. Now, an interface could be network adapter, display adapter, then wireless adapter, like wireless network device that you connect to. I mean, anything that is connected to the CPU, okay? So now how do you get these drivers? All these will be part of your VirtualBox installation. When you install the VirtualBox, it will provide all the tools that you need based on your needs, based on your necessity. You have to install those drivers. If you think you are working on, or you're going to create a virtual machine, which is pure character user interface, then probably you don't need some of the drivers that we are going to install. Nowadays, most of the people basically they try to have graphical user interface because that's pretty easy rather than trying to work with character user interface. Initially, when we started our career, it was pure character user interface. That's where you log in, you get a command prompt, and that's it. That's where you are going to use everything to build the softwares. So now let me go to the software and try to install. But again, the piece that I was going was, so if you go to virtualbox.com, now pretty much this gives some information about what exactly the VirtualBox software is, and it is open source and how they do the builds. So now another point I should have explained is when I say your machine, like a laptop or a desktop, whatever it is, by itself, that machine has some operating system installed. It could be Windows, it could be Mac OS, it could be Linux, whatever it is. But for most of the times, majority of the community uses Windows. So let's talk about Windows. So that's the reason this VirtualBox provides different flavors of distributions. Like, okay, if you are using Mac, how to, now this is the distribution that you have to use to install the VirtualBox on the Mac. If you are using Windows, you have to pick the Windows host. Now in virtual world, we commonly try to use the two terms, host and guest. We should clearly able to differentiate between host and the guest. Guest is nothing but virtualized machine. Host is nothing but the machine that is running your VirtualBox or virtual machines. So your host will be always your desktop, your physical box. And the guest is your VirtualBox. So these are the two terms primarily used whenever you are trying to interact with virtual machines, host, guest, guest host, because within the configurations and everything, you'll be keep seeing those terms. So few more things that we need to understand is this is our, let's say, internet. Now this is your desktop. Now on the desktop, you created your virtual machine. Now desktop has a network adapter. Your virtual machine also has a network adapter. I hope most of them knows what is network adapter is by now. Now this is the internet. This is your home. In your home, in order to connect to internet, you have a router. Now this router, to this router, your desktop is connected. It could be via Wi-Fi. It could be wired. It could be, any means. Now this router is connected to internet. Now within this router, how you are able to access internet from your machine is basically you have something called DHCP service. I don't want to go deeper into the DHCP, but the main purpose of this is basically it is trying to allocate an IP address to your machine, and it does some kind of a translation whenever you are trying to hit google.com or when you're trying to hit any of the public facing websites. That IP address gets translated to an address so that it can go and read the data from internet and get the information back to you. Now, if you see, for instance, when you are connected to internet, in order to find what this DHCP is allocating an address range. These addresses are called IP addresses, and based on the by default, most of the home or residential routers allocate an address range of 192.168. something and something. Usually 1.1 is basically blocked by the router, and 2, 3, 4, so on and so forth are for the machines or the device that you connect. It could be your phone, it could be your tablet, it could be your iPad, whatever it is, MacBook, whatever you're trying to connect. Each and every device gets an IP address. Now these IP addresses is what you can see by using a command called ipconfig. So when I say You will see this range. This is my home. See 192.168.1.21. So now when I'm trying to connect to internet, what this does is this goes and first sends that request to my router, because this machine has no way to directly connect to outside world. It goes and connects to my router. Now my router knows, oh, okay, he's asking for something where it needs to grab some information from internet. Then it goes and connects to internet, gets the data back, and again routes those same packets to your actually allocated IP address. Okay, that's how the communication happens. But now till here it is good. Now what happens between this VM and this host machine? Because this virtual machine is running within the desktop, and this virtual machine technically, can it connect to router, or is that it has to connect to this? There are multiple ways that connection can be done. Those are called bridge and a NAT. These are two different ways where you can connect to network. I should not say internet, you can connect to network. Now, what is the difference between a bridge and the NAT? NAT, as I explained just now, is similar to the process what you see here. If you configure your virtual machine network adapter to use the concept called NAT, called network address translation. That's what is happening here. 192.168.1.1, basically every home will have a public IP. Okay, my internet service provider will allocate a public IP, but within the public IP, there are two things like static and dynamic, but most of them will have dynamic, which is reserved for a certain number of days, and the lease gets renewed and you get the new IP address. Okay, then this IP address is up till your router. It does not go beyond that. Anything that goes beyond this is all the DHCP based IP address range. It could be 192, it could be 10 dot something else, it could be 207 dot something, whatever that you configure with specific to your home network is that IP address range, and all the devices within that home will use only that specific IP range. They don't go beyond that. And that IP address to the public IP address happens using this address translation. Now, when you configure your network adapter in terms of a bridge, sorry, okay, let me do the NAT still. One more point I need to specify. Within the NAT, when you configure your virtual machine as NAT, then there is no communication between your guest and host. The reason being, this itself behaves as if it's like an individual machine, individual device. Okay, now which IP address range you are going to get when you configure it as NAT within the virtual machine? Since this is virtual, the virtual box by itself maintains its own. So let's say this is your virtual box software. This itself has a component called gateway component. Just like the router what you have, the same software component is deployed. Now, when you say NAT, it goes and connects to this, and this goes and connects to your actual router. So this might get an IP address of 192 dot something, which we cannot see, but this give another range like how you configured a range of 192, the same range will be there within this, which could be 10 dot x dot y dot z, which is the default range. You can change this default range if you want, but this is a default range. And hence, if you take the route of NAT, you are probably, let me erase all this stuff. And so the way you get is your home network public IP could be 86.92.x.y. Now your home router will take this, and it could have an DHCP range, IP range of 192.168.x.y. Now, These are all your devices within your home. It could be desktop, then it could be an phone, TV. What else you connect? iPads or laptop, which gets its own address. 168.x.1, x.2, x.3, and x.4. Now in the same concept, now within this desktop, you have a virtual machines running. Right? These are separate devices, though for your desktop physically, but not for your home router. Now in order to manage these three things networking, so as I said, you have NAT and bridge. Okay. So now when you take the concept of NAT within this virtual machine, there is another, think of it like a router that has been software product. I technically don't know the term that has been installed, which all these connect to this and this connect to your physical router. So this gets an address range of 192 and this gets an address range of 10.x.y.z, then y.a or y.b, so on and so forth. So that these all can behave as if they are physical devices and they're totally isolated. This cannot communicate to our host at all. So these are all guest machines, G1, G2, G3. This is your host, H1. This is another host, H2. This is another host, H3. Okay, this cannot communicate to this. The reason being this IP range is different and this IP range is different. This is one kind of network. Now, why you would want to go the route of NAT is, let's say you are installing some web application here and you want to keep it isolated and you don't want anyone to connect to this machine. Then you go with the NAT. It's for security. And hence, by default, when you install VirtualBox, when you create a virtual machine, by default, it will pick the networking route as NAT, configuration as NAT, so that it is isolated by itself, by security. It means things can go out to internet, but from internet, people cannot access this box. It's blocked here. Now let's say, how can this host, if host machine cannot access these boxes, then how or who is going to configure these boxes? How we are going to configure, how we are going to install, deploy? There are, if you want to take the concept of NAT, then if you want to connect or communicate to these things, then there is something called port forwarding, which you need to configure so that only specific IP address devices on specific port can go and communicate to these boxes. So it's totally isolated. It's like, you think like, okay, a firewall kind of a piece is been put in place so that it is totally secured, where no one has any access except only for the authorized people for which that IP address is whitelisted. Now that is one way, and that's how technically in enterprise you have to do. But in order to do the POC, you don't want to take all this route, then you go directly the concept of bridge networking. In bridge, it is similar to what you see here, where it gets an, instead of 10.IP address in bridge, you get an IP address range of 192.168.x.y, x.a, x.b, where x and a's are numbers. They are integers. I mean, I'm not giving specific ones. Maybe it's called 1.2, 1.3, or 1.4. Okay, it directly, now since they are in 192.168 network, all devices can communicate to these boxes. Then the only mechanism to arrest is basically the login, right? Once you know the login, you can connect to that box. I mean, credentials, some kind of a credentials are required in order to connect to that box. And hence, this is very important to understand when you are trying to create virtual machines. It is not that, oh, okay, I'm creating virtual machine, I have allocated RAM, I have allocated CPU, now I have allocated NAT, but how it is connecting to internet, how the traffic is flowing in, how the traffic is flowing out, how can I control my traffic, how can I isolate my box, how can I secure my box? The reason being, you are not going to install antivirus and all those things. It means it's a purely open for everyone. Do you want to take that route or not is the key. And that's how you can control your virtual machine over the internet. And that's very, very important. I mean, making it defaults, yes, makes sense, but you should understand what those defaults mean and what you gain versus what you lose. Hope that helps. Basically, once the virtual machine software is downloaded, then you can, by default in Windows, it goes everything to downloads. So now you go to the downloads and you see the software. Now, I think 10 minutes should be good enough to do the installation. So let me start with the installation. Now, it's pretty simple, like Windows. The main reason why people like Windows, at least for their host machines, is basically installations are free. You don't, I mean, easy. You don't know what's happening behind the scenes, but it operating system takes all that heavy lift and makes the user a easy piece. So basically, like any standard installation tools, you double click that installer, that exe file, and it presents with some options. But here, since I don't want to do any customization or configurations here, I will pick whatever is being selected. Unless if you don't want any Python supported APIs, then you can click this drop down and say, I don't need this feature. But I don't want to customize anything at this point. Let me keep the pre-selected options as it is, and let's go to the next step. Now it is giving or presenting options as, okay, do you want to create any shortcuts and all those things? It's up to you, whatever options you want to pick, but just leave the defaults as it is if you are not sure what options you really need to. Then click next. Now here, as I was saying, right, the network adapter for CPU, RAM, and hard disk, it is like a physical share, but for network adapter, it is going to create a virtual network adapter. And that is what it is going to do. It is going to deploy a network adapter within your host machine on your laptop or on your physical machine. And hence, when it is trying to do that, it is giving a warning saying that, okay, I might lose or disconnect your network during this configuration. 99% of the time, you don't see any network disconnections, but sometimes based on the system's operating system level and the patch level what you are at, you might see a glitch where it will disconnect and reconnect back. So I have done this multiple times. I did not felt any disconnect, so I'm good to go to the next step. Now it is saying, okay, I'm good. Shall I start the installation? Okay, go ahead. Now I'm not sure in your in my screen share, did you see a window popped up saying yes or no? That is basically saying, I am installing this software as a user, but I need some administrative privileges in order to deploy some of the components specific to VirtualBox, like device drivers, network components. It needs to go and update some registries within the Windows environment. So only administrator user can perform those changes, and hence it is giving or asking the permission saying that, okay, is that you are trying to do? So shall I go ahead and do it or not? I said yes. It took the approval and it continued with installing the process, and we are done. Installation is pretty simple, straightforward. Okay. Now I don't want to start. I want to show like how you can start. Let's say finish. Now installation is done. So now once you are done with the installation, there are a couple of ways where you can go and access that. Just like as any Windows application that you deploy, it might create a shortcut on your desktop. It might create an icon on your taskbar, or you can go to start programs, and open the virtual machine. Okay, so all leads to the same thing. And this virtual box is a 64-bit product, and hence if you want to see where it is being technically installed, you can go to see program files. So you have two program files x86 and program files. x86 is all the software that you install as a part of 32-bit, and without x86 is basically 64-bit applications. So you go to program files, then you should see, you don't see as a virtual box, you see as an Oracle, and under Oracle you will see virtual box, and this is where all the software, dynamic link libraries, products, tools, drivers, whatever it is required is being installed and configured into this box. So anytime if you want to go and check if there are no shortcuts, the other way is go to program files, Oracle, virtual box, and there you can see the virtual box exe icon where you can start that program. And the reason why I'm showing this is there are a lot of command line tools that are available to configure some of the items like additional network drivers. If you want to remotely start your virtual machines, give control of virtual machine like status, where it stands, how it's behaving to another machine, then those command line tools are available here where you can communicate to your virtual machine. So once the software is installed, then you go to the virtual box icon. It could be from any place, and now you're at a place where it presents that application. This is the virtual application, virtual box application, where you can create virtual machines. Now, as I said initially, in order to create any machine, it could be virtual or a physical, you need a few components like CPU, hard disk, memory. Then I said network adapter. And along with that, there are a few other components which are, I should not say optional, but they are not like a mandatory piece, but you have like a display adapter, then you have audio, then you have USB. So these are the add-ons that you can add to your machine so that you can interact with those devices to perform some activity. Okay. Now, how do I create the virtual machine? Yeah, we downloaded, we installed, and now how do I create it? So if you want to create any virtual machine, you have to start with an option called new. Maybe you can say file in machine new or the new, both takes you to the same place. Now click new. Now it is saying, okay, give a name to our virtual machine. Okay, fine. I will say CentOS test. Now, where do you want to store this virtual machine? I'll just leave it to my existing folder E, virtual machines, or you can go and say other location, and you can pick whatever location that you really want to. It's up to you where you want to store. Now, what type of virtual machine you are planning to create? Type in the sense here, like what operating system you are planning to install. Your type means per se, not like, okay, something other than the operating system that you're planning to install. Are you planning to install Linux? Are you planning to install Windows? Or are you planning to install some other thing? Because there are a lot of within the, so Linux is one of the flavor of Unix family. So within the Unix, you have Linux and some other flavors like desktop-based applications are also there. So it's asking you those kinds of things like Solaris is another flavor, right? BSD is another flavor. IBM ZOS is another flavor. So it's trying to understand what flavor of operating system you are planning to install on this machine. So now I'm in this, for this session, I'm going to pick CentOS, the Unix operating system, and hence I'm saying, okay, Linux. Now, which version? Yep, of course, I'm going to go 64-bit. I'm not planning to use any 32-bit, so I'm saying Red Hat 64-bit. Again, within the version, there is no need for you to clearly pick the version that you're planning to install if it is not there, but you try to correlate that to appropriate thing that you're trying to use. Because CentOS, you don't see that here, but behind the scenes, CentOS is more or less equivalent to Red Hat, and hence I said Red Hat. And I'm going to install 64-bit, so I picked 64-bit. One thing I noticed is when you install virtual box on your machines, sometimes you will not see this 64-bit operating systems in the list. Most of the times. It means one, your system is not enabled with the hyper threaded. Or if hyper threading is enabled, then it means within your Windows machine, Hyper-V is an Microsoft's virtualization software, just like VirtualBox. VMware virtualization software. VirtualBox is another virtualization software. Hyper-V is also virtualization software. So Hyper-V is from Microsoft. VMware, of course, is from VMware. VirtualBox is from Oracle. Okay, so two virtual machine creation softwares cannot be active at the same time, and hence it will not show the 64-bit. So you need to disable that so you can see that 64-bit from this dropdown. Okay, good. Now you are done with the basic configuration, and now go to the next option. Now, how much memory you want to allocate. Now, how do you decide how much you can allocate? My desktop has 16 GB RAM. Okay, good. Now, within that 16 GB RAM, how much I can allocate to my virtual machine? What you are trying, I mean, the first question that you have to ask within yourself is, what is the purpose of this virtual machine? Are you going to install all the softwares that is running on your Windows machine? Or is that you are going to install the software that is really needed for you to create some kind of a project, prototype, coding, learning, whatever it is? Okay. The reason being, never ever fully allocate the memory that you have on the host to the guest. Okay, that's why you have these marks, which is giving some idea like, okay, to what is, the green means, okay, safe line. So it is clearly saying based on the nature of my machine, safely I can allocate at the most 11 GB RAM. Anything that go beyond, it's in the amber, the orange line, it means I can work, but I don't know when I will crash. Now, if you go here, it is clearly saying I may crash anytime. The reason being your operating system itself needs some memory in order to work. And hence, never ever pick this red line piece. And I always try to pick something which is within this green line. Okay, so I will allocate like around 6 GB. Okay, I'll stop it here. I mean, this is not 6 GB. I mean, yeah, 6 GB, but technically this is not the right number for 6 GB, but more or less it is 6 GB. Now your memory allocation is done. Now go to the next. But again, when you do this memory allocation, you have to understand the operating system that you are trying to install on that machine suffices, or machine requirements are fed with this. Because if you're trying to install an operating system which needs more than 6 GB RAM, then this configuration is of no use. So the parameters that you have to look before creating a virtual machine is what you are trying to install, how much resources you have on your host machine, and the operating system that you are going to install within that virtual machine requirements, CPU requirements, memory requirements, disk requirements. Those are the key. It is not that you cannot change these parameters after, but I don't like that route to take. It becomes a trial and error, right? Because you're installing something for which already there is a document which tells how much the hardware requirements are. Those hardware requirements make the virtual machine requirements for you to install that software. Usually for CentOS, they say 4 GB recommended, but you can still try installing on 2 GB, but I don't like to, and hence I'm picking 6 GB as a 2 GB as buffer, so that any additional softwares that I install can be accommodated. Okay, that's the next. Now disk. Now RAM is done, random access memory is done. Now hard disk. Now how much disk space you want to allocate? I'll just go with the 8 GB disk space. And here in the virtual world, there are, let me give some details about the hard disk here, because how this hard disk is being allocated. In virtual world, everything is files, because they are not like physical devices. So that's why in the step 1, it is asking where you want me to store all these virtual machine files. Hard disk is a file, RAM is a file, CPU is a file, I mean, what that file contains? That file contains the configurations and information, like bootstrap information, which is required by VirtualBox to communicate to the hardware. Now, this hard disk comes into the play. Like, technically, whatever hard disk space that you're allocating behind the scenes, it is occupying on your physical hard disk. Okay, but now when you create this hard disk, there are multiple or different options they provide. Do you want this hard disk space to be dynamic or static? Now, apart from those two options, do you want to pre-allocate or dynamically allocate? Different routes. Now, what are the advantages and disadvantages? Now, let's do the pre-allocation versus dynamic allocation. Pre-allocation, if I say 8 GB disk space, it creates that 8 GB file on your hard drive, even though you have not totally used that 8 GB space. It means it is pre-allocating that much of space on your disk so that it is guaranteed you'll always have 8 GB space available to your system. And on top of it, your virtual machine does not have any overhead of allocating the space as and when it requires. Okay, that's one option. Another option is dynamic allocation. You are saying, yeah, my maximum limit is 8 GB, but you start with 1 GB and you keep increasing as and when you need. That's what the dynamic allocation is. So it's up to you which route to pick. There is no hard rule. You see a little bit of performance implications when you take the dynamic route versus the pre-allocated route. That's one thing. And once these disks are created, one good part about these virtual machines is you can detach and attach these disks to any machines with that same operating system flavor. Let's say I created an hard disk, disk file, which is specific to Linux operating system. Okay, now I install some softwares. Now I'm creating one more virtual machine. I can attach this disk to that machine so that it automatically takes those configurations and start booting it. And the same concept is used in cloud environments. It could be a cloud, it could be AWS cloud, it could be Google Cloud. That's why when you're creating virtual machines, you will have disk space, like there's a blob storage, right? You have those ESB storages where you can attach and detach those disks. That's why when you terminate your virtual machine, those storages, it will ask, do you want to terminate those disks as well? So those kinds of concepts can also be implemented within your VirtualBox environment. But for now, I'll go like create virtual hard disk now, or do not add virtual disk now, so that I can pick a disk which is already available. It's up to you, but I'll just say that just go and create the virtual disk now. See here it is saying you can pick another virtual disk which is already available. So it is referencing my disk which is already there, but I want to create a new one. Now say create. Now, which type of a file, virtual disk file you want to use? This is also another good thing. As I said, virtual machine, there are different softwares, right? Hyper-V, VMware, VirtualBox, and there are a lot of other tools which are not that popular, but there are many. But now, if you want to migrate from VirtualBox to VMware, for some reasons, I don't know, like Mac, you're going to Mac, VirtualBox is no more not supported properly, let's say, and you install VMware product on it. Now, the virtual machine that is created in Windows, if you want to use on a Mac machine which is running VMware, can I use it or not? If you want to get that flexibility, then you have to use something called open virtual formats. There are certain standards that are defined. So if you want to take that route, then that's where these options come into the play, so that the hard disk file that you created is portable to any of the virtualization softwares that you use. So this is the time for you to decide what is the flexibility that you are looking at for the virtual machine that you're creating. Okay, for now, I'm going to stick with the VirtualBox, but again, you can go with the virtual hard disk, VDH, and VMDK. These are all the formats that are flexible enough to be migrated to another virtual machine software. Once you create a VirtualBox disk image, you cannot use this hard disk file image for VMware. It is not supported because it does not know what it is. Now click next. Now this is what I was saying. Dynamic allocated or fixed. If I say fixed, 8 GB disk file is created. If I say dynamic, it starts with some X bytes or X GB, then it goes and goes and goes till 8 GB is hit. Once 8 GB hit, it stops there. Then you have command line tools to increase that size of the 8 GB to whatever you need. Click next. Now, disk size. So here it is giving me how much is your file disk. I said 8 GB, I'll keep it, but if you want, you can increase as well. But I'll just stick to 8 GB and say create. Good. Now your virtual machine knows what type of configuration your system has. It's a raw box, like a brand new desktop that you purchased a motherboard, you purchased a cabinet, you purchased a CPU, you purchased RAM, you purchased hard disk. Everything is screwed in tight, done. But there is nothing in it except the power is there, of course, but there is nothing else. Now, if you try to start that machine where it has nothing installed, what is the first thing that you see whenever you start your laptop or desktop or anything? You see the BIOS configuration, basic input output configurations that you can do from the BIOS. And if you try to start this virtual machine now that we created where it has nothing installed, the same thing you will see. So I'm starting, it's like I'm powering on. So it is saying you don't have any startup disk. Okay, I'm not going to pick anything. So this is where you can click F12 and go to BIOS, but I did not click F12. It was so quick, but maybe let me try again. Power off the machine. Let me put my hand on F12. It's so fast. See, it is giving me the boot menu loader. So when I clicked F2, it is giving the boot menu, like where you want to start your machine from. You want to start from network, you want to start from CD-ROM, you want to start from floppy drive. And you see the same kinds of, the menu could be different in your desktops or laptops, but it all depends on the version of the BIOS that it is running. But anyways, since nothing is there on that machine, it doesn't know what to do. It doesn't know what to load. It doesn't know what to read because everything is in the raw format. Your hard disk is not formatted. Okay, you don't have any software installed on it to start your applications or to start the machine. So now in order to do that, what you have to do, you have to install the software, you have to install the products. But how do you install the products? There is no physical CD drive or physical floppy drive attached to this machine. So we will attach our physical CD drive as a virtual appliance to our guest machine. So now how can I change those configurations? Because when I'm creating that virtual machine, I did not attach any CD drives or anything. So if you want to change any of such configurations, you can go to the settings. So click settings. Now here you can see your system, your motherboard is basically, that's where you have the RAM, then you have floppy drive, hard drive, CD drive, and network adapters, all these things. So now if you go to the display, it's like your monitor, what type of, by default, it uses a graphics controller like WMSS VGA, which is basically the VirtualBox specific. Then you have storage. This is where you can see all the disks. So now here I go to the CD drive and I'll attach. So I'll go to, so now how do I attach? I have already downloaded the operating system. Now, where do you get the operating system? And I'll get to here, what is the difference, but just say CentOS Linux Stream, go to x64 and you download software. It is like 8 GB software. So I pre-downloaded, it is going to take longer time. So when you download, by default, it goes to the downloads folder. So I went to my downloads folder. I have my CentOS and open. Now, when you download, it is going to download in the form of an ISO image. ISO image is nothing but like your CD image that you have. Like when you want to write anything on your DVD or CD content, CD drive, you need an ISO format so that it can be written to the drive. So that's why they provide the ISO format. Now you can attach that ISO format to your virtual CD drive so that when you start the machine, it feels as if an physical CD disk is inserted into your drive and start reading that content, and it will do the next steps to install the software. Okay, my CD drive is attached. Now I don't want to go beyond network and all those things, but let's first see how it shows here. Now, once you click CD, here you see for the storage, the controller IDE, it says CentOS DVD disk 9.2 GB. Okay. Now, let me do the other settings. So go to the settings. Now under the system, you're done with it. Now processor. How many CPUs you want to allocate? I'll say 2 CPUs because I have like 8 CPUs, but I want to go with 2 CPUs. So you slide this, or you can type in whatever number you want. And to what extent you want to cap these 2 CPUs? I'll say 100%. That's okay because I have 2 more CPUs, no more than 2 CPUs as a buffer. So my system will not have any resource hungry scenario. Now display, it's as okay. Within this after processor, now go to the acceleration. This is your virtualization acceleration. I always try to keep them as default. I don't tend to change these configurations unless you see some issues. But with respect to software that we are installing with CentOS or Red Hat or Windows, I have never seen an option place where we have to go and change this option. So just stick to the default options with acceleration unless you have an high-end display adapter. Now storage, we discussed. Audio. So again, this audio is basically your physical audio on your machine, audio drivers or audio adapter that you have on your machine. It's up to you if you want to install, or else you can uncheck this box so that you will never have audio from that machine. Now network. As I said initially, you can have up to 4 network adapters within the virtual machine that you're going to create, but you can extend this to additional 4, but you have to do that via command line prompt. Now, network adapter, now this is enabled, and by default, as I said, it will pick the option as NAT. But if you want to change, come here and pick whatever you want. Okay, though, here you see a lot of other options. Maybe I'll give some overview. I may not go much deeper into it. So NAT, I explained. Bridge, I explained. You see along with the NAT, is NAT network. NAT network means just like your home network, you can create a NAT network with the address space that is been allocated by the VirtualBox. Means if you are creating 3 virtual machines within your host machine, and if all the 3 machines are connected or configured to have NAT as their network adapter, NAT as an option, but even though they are not, you want to communicate between those 3 devices, but those devices should not be accessed within the host machine. So for instance, when I say this is my desktop, like this is my host, and in the host, let's say I have 3 guests, guest 1, guest 2, guest 3. Now host has 192 IP address, as I said. This has 10 dot, this has 10 dot, this has 10 dot IP address. Now, if you want these 3 to be connected, but do not connect to host, then you use NAT network, so that you are building your own network within the virtual machine world. But if you don't want any such connections, then use just the NAT. So all are isolated to themselves. The question could be, why you would want to do this? Yes, of course. I want to have my Tomcat running here, or any web application server. I want my database to be running here. I want my storage to be here, like files or repositories, whatever. Then you take that route. or you have only two virtual machines, they both should be communicated but should not be connected outside world, then take this route. Or maybe this is another one application which is running my own photo sharing. This is another application which is running my disk sharing. It's another application which is running for people who are logging in to browse internet or anything. You want to give that? Yeah, then take that out of NAT. So it all is up to you how you want to configure that virtual machine world. That's how powerful these softwares are nowadays. You can create your own data center kind of a network with all the configuration that you are looking for. But again, the downside is you need to have much powerful host machines. So, but anyways, so for now, I will pick the NAT and I click OK. Now, before I erase this diagram, other question might arise is, okay, I want this private space communication, but at the same time, I want only this machine to be connected to my host. Now, in that scenario, you will see the benefit of having multiple adapters, where one of the network adapter, okay, one of your network adapter will connect to 10 dot network, and another network adapter will connect to your 192 network. That's why you'll have multiple adapters option. And in real world, if you see the physical servers in your data centers, in the actual servers, every server will have at least two network adapters. One will be used for input traffic, one will be used for output traffic, or they will be clustered, or one will be used as failover. All those things, all those scenarios, all those configurations, you can try in the virtual world, see how it behaves, and then design, architect, and implement as the physical box. Because purchasing as a physical machines, trying all this out, and at the end you say it is of no use, versus trying all those options in virtual, you see the benefit of it. That's why these virtual machines are so powerful and very useful. Okay, now I'll say NAT and I'll say okay. And again, these configurations can be changed after installation anytime you want. You can add, you can delete, you can change, you can modify. For now, I'll pick NAT and I'll say, okay, I will show as an update after installation to go to adapter 2 and configure that bridge network. Okay, serial ports. I don't have any connected to my machine. I used to have a dot matrix printer, which is serial port, but I threw away last year, so I cannot show that. But serial ports are any communication that you want to do via serial port. These are all some 13 pin. I don't remember all those things, but like it could be a printer, it could be a hardware device where you want to communicate or read or write or do some kinds of mechanism. Like you want to program some hardware devices. Most of the hardware devices might be serial port. Nowadays they're USB, but serial port devices, communication devices there are a lot of devices that you want to connect to them and start doing some programming, then you can do that option as well. USB, all know. There's nothing much to say. You have lots of USB devices that you get connected. And if you want to have that virtual connections established to it, then you need to have this driver installed. So by default, it is having that controller configured. Now, shared folders. If you want to share any files from your host machine to guest machine, then you can provide that access here, that folder location here, and you can grant whether you want to read only or you want to have read and write, all those options you can provide. Now, you think like this is like some kind of an Samba service where network share is there, which you want to mount that or connect to that so that you can access the files directly. And that is what this is doing. The reason being, once you create a virtual machine, for instance, you have a program file, which you might update from Windows machine and which you might need to run that from Unix machine. So you can share that folder and directly go to that file and execute it. So any such scenarios where you want to share a file between two machines, then you can drop that file over here so it can be shared. I think pretty much done with the options that you see here. Now let's click OK. Now the options what you changed on the settings will be reflected here and shown as a summary. Okay, now let's kick the tires on, say start. Okay, good. Now you feel as if a physical disk or a drive is being inserted into the drive and it starts the installation. So now I will say, okay, install the CD. I don't want to test the media because already tested. Now click enter. Now these are all the default options that you see for any CentOS flavor installation. Now it is trying to capture all the information that the virtual machine has. But for the software, the CentOS software that you are installing, it doesn't know whether it's virtual or physical. It treats as if it's like a physical box or a physical machine. And you see the activity here, it means it is as if reading from the CD drive. And all the configurations that you applied for this virtual machine are being represented here in the form of an image so that you know how many virtual CPUs are, how much disk space is there, how many network adapters are enabled, are there any shared folders that are enabled. Okay, this is the hard disk, this is your CD-ROM drive, this is your audio device controller. Okay, now this is your welcome screen. Yeah, by default, of course, I'm going to pick English. Then say continue unless you want to pick some other language. Now here it is giving an summary where it says what type of keyboard. Because I picked English, it is by standard, it's picking the US English. Then language support is English. Installation source is my CD drive. Then software selection. By default, it is GUI based installation. I'll just keep that as it is. I don't want to change that. Now, automatic partitioning. So I'll go there, right? Then date and time. Yes, I'm picking the New York time zone, but based on the location where you install, you click this and change accordingly. But if you are planning to install this like a database product or anything, usually they try to pick a UTC time zone. So this is the place where this is the time for you to pick that kind of a time zone change. Of course, you can change the time zone after the installation as well. Now installation description, basically how, I mean, you see, now we allocated the 8.x some amount of GB disk created, right? Now the installation is asking how you want to partition this disk, how you want to install the software so that the disk can be partitioned and the software can be installed and you can use the product. There are two ways. One is automatic, one is custom. In advanced portion, we'll go the custom route, but in the automatic, let's keep the session for automatic so that it takes the defaults and start doing the installation. When you install Windows, or I mean, of course, most of the times you get the machines pre-installed Windows. So you will see C drive, and sometimes you will see hidden drives when you go to the disk manager, where all the drivers, recovery media, everything is stored. Okay, but in Unix, you see more than that. But while the installation is going on, I will explain what those partitions are. But you will have something called swap and all those things. But let me take the automatic installation, and then I will click done so that the partitions that default it requires can be made. Now here it is. See, it says I allocated 8 GB RAM, but requires 13 GB of disk space, which is including for 6 GB software and 5 GB for the swap space. So I think, let me extend the time to take that. So this is your disk, right? This is your disk of 8 GB that we created. In the virtual space, I said, this is my hard disk. Now, the differences that you see between Windows and Unix or Linux, because this is the flavor that we are going to use. In Windows, you will see C drive, and everything is within this. In Unix, you will not see like drives. You will see everything as mount points. Right? So C is nothing but slash, like root. This is called root. In Windows also, this is basically called root only, but they call it a C drive. But in Windows, a root could be C or a root could be D, because it's just a drive letter that is assigned to the root folder. What is root in Windows? Basically, the place where you install the operating system, the Windows folder. The Windows folder where you see the operating system that is being installed. In Unix, everything is under mount panel called // which is the root. Under the root, it starts creating the partitions. Now you could say, does Windows does not have partitions? Yes, it has. Windows also has partitions, but in order to install the Windows software, you don't see those partitions. It directly goes and deploys all the library software that is required within that root folder. I should not say within that root folder. Now, you saw something called swap, right? Swap is applicable for Windows as well as Unix. It is not specific to Unix. Then what is the swap? In general, the meaning of swap means moving in and out. And the purpose of the swap is to support applications that you try to open, many applications within the system, so that whatever the, so for instance, let me take the example of Word application to clearly explain the MS Word. Many of them knows what is MS Word application. Let's say I have an MS Word application of 10 GB file. Okay, it has images, content, lot of things, or maybe it's a 10 GB is overkilling, maybe it's a 2 GB file. Okay, my machine has 1 GB memory. Now, can I open this file here? Because within this 1 GB, I have operating system running, my MS Word application running, plus you're trying to open a 2 GB file. Operating system needs, let's say, 512 MB RAM. I'm talking about RAM here. It is random access memory, not your hard disk. My Microsoft Words maybe need 64 MB. Now remaining is, for sure, I know it is less than 2. Now how can I open this file? But technically, you can still open the file. It does not say anything. It will open the file. But what happens is it uses something called pagination, called page file. You'll see page file.sys, which is a hidden file. And if you open this file, it will be like 64 GB. It will increase to the limit that you specified within your operating system configuration. If you go to my computer advanced configurations, you will see what size your page file should be. You will say maximum, which will be always your entire disk space. And this page file will keep growing as and when you try to open more and more applications, which are technically not suitable to fit within this RAM. But how this swap, this pagination happens is the concept called swap. Anything that is least recently used will be pushed to pagination, and anything that is really actively used will be kept in the memory. And that's how you're able to see the 2 GB file. Because technically, when you open the MS Word file of 2 GB, you are not going to see entire 2 GB document. You'll page down, page up, because I'm a human. I can read only certain things to certain extent. I cannot read entire 2 GB in one shot. So when you go to keep on going next page, you will see hourglass taking some time to load that page into the memory. What is happening? Because it is having swapping. It is pushing something that is not used most frequently into pagination, that swap space, and loading the stuff that you really need, that you're really asking for to currently see into the memory. That's what this pagination is happening. And this in Windows, nowhere you will see that. Because the way Windows software is built is hide everything, make user easy. That's why if it works, it works. If it does not work, technically. Okay. Done. Yes. So you don't have enough space available to install Linux operating system. So it is giving an options for me to shrink or remove the existing partitions. I'll just say reclaim space. So automatic partitions done. Now other option is root password. In Windows, same option we call as administrator. Right? When you log into your Windows machine, it could be laptop or anything, you log in with your login ID. But when you want to do any configuration changes, you need administrative privileges. In the same way, in Unix, such administrator user is called as root user. So it's asking you to set the root password. Okay, pick something. It has a dictionary which says my password is weak. I know that should be fine. Done. Okay, now it says begin installation. Now, when I click the begin installation, what it does is it starts creating the partitions, then starts deploying the software libraries and files, everything to do the installation. So at this point, what I would like to do is I want to minimize and then show the already installed software rather than going through all the steps, because at this point we have to just sit back and relax and let it do its work. It doesn't do anything beyond that. So I'll minimize this for the time being. Okay, now I'll start my machine. So this is now, once that installation is done, how the machine looks like is what I'm showing here, which is powered off. So I'll say start this. Because the one that is already running behind the scenes, it'll install, it'll reboot a couple of times, and it'll ask you to enter the some other information, additional information, specific like accept some license agreement and all those things. Once all those license agreements, everything is done, then you will see an option where you can log into the operating system, and it will give you the graphical user interface where you can log in and start using the platform. Okay. But yeah, once you log in, just like your Windows login, you will be represented with this screen. Of course, every UI has their own design. So if you click on activities, you can see all the things. Or if you want to go to applications, click on this. And I mean, I pick only basic things because it's a virtual machine where the goal of this machine is to have some Python or a Java or whatever it is running it, and it doing some kind of an activity. So usually people tend to keep the virtual machines as light as possible so that only required number of tools, softwares can be installed so that resources are not underutilized and wasted. Basically, I should not say underutilized, basically are not wasted for the tools that are not being used. Because in Windows, we just go and start installing the software. At some point, we'll feel as if, okay, I have installed this, but I haven't been not using this from many months. Do I really need that running in my machine? So that's why there's a purpose for the VMs. So in order to keep that purpose, we have to install and stick to the tools that we install on those boxes as the minimum as possible so that the resources like CPU, memory, hard disk that are allocated are really used for that purpose. And in Windows, in order to get the IP address, usually what we do, we use the command called ipconfig, right? But remember in Unix, it is not ipconfig, it is called ifconfig. Then it will show you the IP address like 10.0.2.15, which I cannot ping from my host machine. And of course, I configured another adapter which is for the bridge network, which I can ping from my host machine. So this is by the NAT, this is by the bridge. But we'll do that in the later session as how that configurations can be done, how can we do port forwarding, and how can we configure them and bridge them.
Okay, I have like 2 points. So when you choose type, right? Type on the very first slide, like we are choosing Linux. Other
While
layers.
creating the virtual machine.
I mean, I didn't see Windows, so I have to choose others if I want to use
No,
Windows.
no, no. You will see. Let me see. If I say new,
Yeah.
see Microsoft Windows.
Okay, okay, it is there.
It'll show. See?
Yeah, yeah.
Windows, Linux, Solaris. Or
Okay,
there is something
probably
like you
I
want to
missed
install
it.
Chrome OS or anything, maybe it will fall under other. Technically speaking, this is only metadata. You don't see any difference. If I say Windows, and I
Correct.
can still install Linux because I'm buying my desktop to install Windows, but I change my mind. That's okay. It's only the
And
metadata that will be stored within the files to tell, oh, okay, this was a tend to create a Windows machine, but you install Linux.
yeah, one more point I want to add, because I see we have like a couple of beginners, right? Normally, in our laptops, right, the virtual technology will be disabled, right, in by default in our BIOS, in our physical machines, whether it's a laptop or desktop.
If it is
We
Windows 10, it is enabled by default.
Okay, okay. Otherwise, we need to change
Correct.
that feature, right?
In
Okay.
the BIOS, we have to go and enable that hypervisor.
Correct. I'm using Windows 10, but it was disabled. I mean, today only, like, we were installing our
Oh,
first
okay.
virtual
I don't
machine.
know that. Yeah. But
Yeah.
usually in Windows 10, the reason being Hyper-V is installed.
Okay.
So in order to make that product active, that hyper-threading needs to be enabled.
Yeah, I just restarted, then I just enabled it. Even though I'm using Windows 10, I
Oh,
enabled
okay. That's
my
good to know.
virtual.
Okay.
Yeah,
Maybe I'll just create some screenshots of that and show it in the next class.
sure.
Generally, what type of settings we will use for communication of different VMs, network level setting, NAT or a bridge?
NAT.
NAT only.
Yes. And that is the recommended way you have to use. The reason being, when you deploy your solution into the production environment, it's NAT, it is not bridge.
Okay.
So you
I
know
think
what implications, how to connect, how to communicate, what firewall ports to be opened, all those things you can clearly document, and you will have that approach plan in place so that it becomes easy when you deploy the solution to the physical world.
Okay.